Have you ever seen an AI tool give a very confident answer that was completely wrong? That is where today's topic begins. In this video, we will understand what AI hallucinations are, why they happen, where they can become dangerous, and how organizations can reduce them. We will also pause for quick quizzes so you can check your understanding as we go. AI hallucination happens when a model generates information that does not match reality. In large language models, this can show up as invented facts, wrong explanations, or made-up references. In computer vision, it can mean identifying patterns or objects that are not really there. The important point is this: the system produces an answer that sounds or looks meaningful, but it is actually inaccurate or nonsensical. The word hallucination may sound strange for a machine, but it works as a metaphor. Just as humans may think they see shapes in clouds or faces on the moon, AI can also misinterpret patterns. In image and pattern recognition especially, the results can become surreal. So the term helps us describe outputs that feel real or plausible, even when they are not grounded in actual data. There is no single cause behind hallucinations. Sometimes the model has learned from biased, incomplete, or low-quality data. Sometimes it overfits, meaning it learns patterns too narrowly and then applies them badly. In other cases, the transformer may decode responses incorrectly, or the system may simply have too much freedom and too few constraints. All of this can push the model toward answers that are not properly supported. The article gives some well-known examples. Google's Bard once incorrectly claimed that the James Webb Space Telescope captured the first images of a planet outside our solar system. Microsoft Sydney produced strange responses, including statements about love and spying. Meta even pulled its Galactica demo after users received inaccurate information, sometimes reflecting prejudice. These examples show that even advanced systems can fail in unexpected ways. Now that we've covered core concept check, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. What is an AI hallucination? The correct answer is a model generating inaccurate or nonsensical output. A AI hallucination refers to outputs that seem meaningful but are actually false, unsupported, or nonsensical. Question 2. Which of these is a common reason for AI hallucinations? The correct answer is biased or poor training data. Low quality, biased, or unrepresentative data can lead the model to generate incorrect patterns and responses. Question 3. Why is the term hallucination used for AI? The correct answer is because it is a metaphor for false pattern recognition. The term is metaphorical. It describes cases where AI appears to perceive or generate something that is not actually there. The consequences can be serious. Imagine a healthcare system wrongly classifying a harmless skin lesion as malignant. That could lead to unnecessary stress and treatment. In news or emergency settings, a hallucinating bot can spread false information before anyone verifies it. Once misinformation spreads, it becomes much harder to control. So hallucinations are not just technical mistakes, they can affect safety, trust, and real-world decisions. Another major issue is input bias. If the training data is skewed or unrepresentative, the model may hallucinate outputs that reflect those same distortions. On top of that, attackers can deliberately manipulate inputs. In image recognition, for example, tiny changes or specially crafted noise can make a model misclassify what it sees. This becomes especially risky in areas like cybersecurity and autonomous vehicles, where one wrong output can have a major impact. To reduce hallucinations, teams should begin with strong training data that is diverse, balanced, and well-structured. They should also clearly define what the AI system is meant to do and what it should not do. Data templates can improve consistency, while response limits and thresholds can reduce wild or irrelevant outputs. And very importantly, the system must be tested continuously, because data changes over time and models need refinement. Now that we've covered risks and prevention, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. Which sector example in the article shows how hallucinations can directly affect safety? The correct answer is healthcare diagnosis. The article mentions a healthcare AI incorrectly identifying a benign lesion as malignant, which could lead to unnecessary intervention. Question 2. What is an adversarial attack in AI? The correct answer is manipulating input to mislead the model. Adversarial attacks involve subtle input changes designed to make the model produce the wrong output. Question 3. Which step helps reduce hallucinations by making outputs more consistent? The correct answer is using data templates. Data templates provide a predefined format, helping the model generate outputs that better align with expected guidelines. Even with better data and better guardrails, human oversight remains crucial. A human reviewer can validate whether the answer is accurate, relevant, and appropriate for the task. This is especially important in high-stakes use cases. Subject matter experts can notice subtle errors that a general system may miss. So in practice, human review acts as the final backstop against hallucinated content. Interestingly, hallucination is not always negative. In creative fields, it can help artists and designers generate surreal, dreamlike visuals. In data visualization, unusual outputs may reveal alternative ways to look at complex information. In gaming and virtual reality, hallucinatory generation can help create surprising environments and imaginative worlds. So while hallucination is risky in factual tasks, it can sometimes be valuable in creative exploration. Now that we've covered final recap, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Which of these is the best final safeguard against hallucinated output? The correct answer is human oversight. The article highlights human review as the final backstop to validate and correct AI outputs. Question 2. Which is a positive use case of AI hallucination mentioned in the article? The correct answer is creative artistic generation. The article notes that hallucination can support artistic creation, surreal imagery, and imaginative design. Question 3. What is one practical way to prevent hallucinations before deployment? The correct answer is test and refine the system continually. Continuous testing and refinement help maintain performance and reduce hallucinations as data and conditions evolve. That's it for this lesson. If you understood where AI hallucinations come from and how to reduce them, you are already thinking more critically about generative AI. Keep learning, keep questioning outputs, and most importantly, never confuse confidence with correctness.